uh, Coming to the next concept, how to find articulation points in a given graph. Looking into the graph, it is difficult to say how many articulation points are there in the graph. Why means, if the graph consists of small number of vertices, then it is easy to identify the articulation points in the graph. For example, see this graph. This graph consists of only 6 vertices. From this, we can easily tell how many articulation points are there in this graph. But whereas if number of vertices increases in a graph, then it is difficult to find out articulation points in the graph. Therefore, there is an algorithm which is used to find articulation points in the graph. This is very important algorithm. So please look at the algorithm. And also one more point is finding articulation point. AP stands for articulation point in a graph is an application for DFS. So what is DFS? Depth first search. DFS and BFS are the graph traversal techniques. See the algorithm to find articulation point. There are totally 4 steps in the algorithm. First, see the step 1. The first step is to construct the DFS tree for a given graph G. So see the example. I am explaining the algorithm along with the example shown in the next page. So see the first step. What is the first step? You have to construct a DFS tree, and along with that you have to provide DFN. DFN stands for depth first number for each node according to the order of the traversing. See the example here. So this is the graph. This graph consists of total 10 number of vertices. This is the DFS tree for the graph G. So I hope you all know how to construct a DFS tree. For example, take the first node as a starting vertex. So adjacent nodes of 1 are 2 and 4. You can visit any vertex. I am visiting vertex 4, and along with visiting, I am keeping the depth first numbering along with the vertices. So after first vertex, I visited fourth vertex. Next, what are the adjacents of 4? Adjacents of 4 are 3 and 1. 1 already visited. Next, I visited 3 and making DFN as 3. And next adjacents of 3 are 10 and 9. You can visit any vertex. So I am visiting vertex number 10 and making DFN as 4. And next, for 10 there is no adjacent vertex, so apply backtracking. Coming to the node 3, next to adjacent is I am taking as 9. Either you can take as 2 or as 9. I am taking as 9 and giving numbering as a 5, and there is no adjacent vertex to the 9. Again apply backtracking, and next adjacent for 3 is 2, so I am visiting the vertex 2 and given numbering as 6. And coming to the 2, there are 4 vertices adjacent to the 2, 1, 5, 7 and 8. 1 already visited, and next I am selecting 5, so giving number as 7. Next vertex 5 adjacent is 6 and giving number as 8. There is no adjacent vertex from the 6, so apply backtracking, come back to the 5, and next adjacent I am taking for 5 as 7. Sorry, there must be one adjacent edge between 5 and 7. Please note down that. And next taking as 7, and adjacent for 7 is 8. I am taking as 8. So for 8 you are having 2 or 3 adjacents, 2, 5 and 7 already visited. So this is the DFS tree for the given graph G. Students, please note this, add this edge between 5 and 7. So this is the first step. Hope you all clear about the first step. So what is the first step in finding articulation point? Construct DFS tree and mention depth first numbering in the order of traversal of vertices. That is the first step. Coming to the second step. So what is the second step? Add back edges in the DFS tree. Then what is back edge? Back edges are edges which are present in the original graph but not present in the DFS tree. So see here, So this is the original graph, this is the DFS tree. So you have to identify what are the edges that are present in original graph and which are not present in the DFS tree. So identify first how many edges are not there. First one, 1, 2 edge is not there in the DFS tree. So you represent back edges as a dotted lines. So 1 to 2, and next one, which are edges are not there in the DFS tree compared with the original graph. Next 2, 7 edge is not there. So 2, 7, 1 back edge. Next 2, 8 edge is a back edge and 8, 5 edge is a back edge. So there are total 4 back edges. So if you want to compare total number of edges here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges are there. Here there should also be 12 edges. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sorry. How many edges are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and one more edge is 5 to 7, 13. Here also 13 edges are there. So therefore step 2 is adding back edges in the DFS tree. So again repeating, what is a back edge? Back edges are edges which are present in the original graph but they are not present in the DFS tree. Back edges are represented by the dotted lines. Direction of back edge should be from greater DFN to the lesser DFN. So here greater DFN is 2 and lesser DFN is greater DFN is 6 and lesser DFN is 1. Back edge direction should be from greater DFN to the lesser DFN. So hope you all have understood step 2, step 1 and step 2. So what is step 1 in finding articulation points for a given graph G? Step 1 is construction of DFS tree and also mentioning depth first numbers in the order of traversal of vertices, and step 2 is adding back edges in the DFS tree. What is a back edge means? Back edges are edges which are present in the original graph and which are not in the DFS tree. In the next class, we will look about the next 3 steps. Thank you.